Hey there, have you ever looked up at the sky and wondered, why is the sky blue? Well, you're not alone. It's a question scientists have been asking for centuries. In this video, Why the Sky is Blue Part 1, I'll break it down in simple terms. By the end, you'll understand how light, the atmosphere, and even your own eyes all work together to color the sky. Let's start with something we all experience: a clear blue sky on a sunny afternoon. You've probably noticed how deep and rich the blue can be, almost like a painting. But here's the twist: space itself isn't blue at all. If you were an astronaut on the moon, the sky would appear pitch black, even with the sun shining. So the color we see must come from something happening in Earth's atmosphere. Here's a little-known fact: sunlight may look white to us, but it's actually a mix of many colors: red, orange, yellow, green, blue, indigo, and violet. You can see this mix when a prism or a rainbow splits sunlight into separate bands. Each color travels in waves, and those waves aren't all the same. Red light has long, slow waves. Blue and violet light, much shorter and faster. This difference plays a huge role in how the sky gets its color. Now let's zoom in on Earth's atmosphere. It's filled with tiny particles, mostly nitrogen and oxygen. When sunlight enters the atmosphere, it doesn't just pass through like a laser beam. Instead, it bumps into those particles and gets scattered. And here's the key: shorter wavelengths, like blue and violet, scatter much more than the longer ones, such as red and orange. This type of scattering is called Rayleigh scattering, named after the British scientist Lord Rayleigh, who explained it in the 1800s. So what does that mean for what we see? Well, when you look up at the sky, you're not seeing sunlight coming straight from the sun. You're seeing the blue light that has been scattered in every direction. It's like the atmosphere is constantly bouncing blue light around, filling the sky with a soft blue glow. Meanwhile, the red and orange light passes through more directly, which is why you don't see it much during the day. It just keeps on going. But wait, here's a smart question: if violet light scatters even more than blue, why isn't the sky violet? First, our eyes aren't very sensitive to violet. Most people just can't detect it well. Second, there's something called the ozone layer in our atmosphere that absorbs some of that violet light. So even though it's scattered, it doesn't reach us in large amounts. That's why our brains interpret the dominant scattered light as blue. Before we wrap up, here's something cool: the color of the sky isn't always the same shade of blue. It can look pale at noon and deeper in the late afternoon. Why? Because the angle of the sun affects how much atmosphere the light passes through, and that changes how much scattering happens. Humidity, dust, and pollution can also influence the color, making it appear whiter, hazier, or even slightly gray. And there you have it. The sky appears blue because of Rayleigh scattering, and how our eyes and brains react to the scattered light. It's a mix of physics, biology, and a little bit of atmospheric magic. But we've only scratched the surface. In Part 2, we'll explore what happens during sunrise and sunset, why the sky turns brilliant shades of orange, pink, and red. So if you've ever wondered why sunsets look like fire, don't miss the next episode. Like, subscribe, and ring that bell for more easy science videos. Thanks for watching.